Welcome to Newton's laws of motion. Newton has 3 laws of motion. The first one can be summarised with the word inertia. Essentially, if an object is travelling and it has a velocity, it will not change that velocity unless a force acts to change it. Remember that velocity is composed of a value, a magnitude, or a speed. For example, it might be 15 meters per second, and it also has a direction. To change either of those things, you would need a force to do so. So the concept of inertia is that an object continues doing what it was doing before unless a force acts upon it. Newton's second law is this equation here, F equals ma. So we know that an object will continue doing what it was doing unless a force acts upon it, and this is what that force does. The acceleration, which is the rate of change of velocity, the acceleration experienced by an object depends upon its mass and the force that's applied to that mass. So if we have an object and it has a velocity of 0, if we apply a force to it, let's say 10 newtons, then we would also need to know the mass of the object if we were going to calculate its acceleration. So here's an example. F equals ma. The acceleration is going to be equal to F over m, 10 newtons divided by 5 kilograms gives us an acceleration of 2 meters per second squared. Newton's third law of motion is that every action has an equal and opposite reaction. Essentially, what happens is that when a force is occurring, it happens in a pair, an equal and opposite pair. You've seen this when you have analysed an object sitting on a surface. Acting at the centre of gravity, we have the weight of the object, which is mg, but we also have the table responding and pushing upwards, and that's the resultant force. So you've seen this sort of thing before. And what happens here is that the object remains stationary because there's no net force on it. The forces cancel each other out and the object is stationary. Situations where that doesn't happen are things where, for example, you might have a rocket ship. So if you have a rocket and it is firing out fuel, then what's happening here is that the fuel is being ejected with a force, and the opposite force that's also generated at the same time is applied to the rocket ship. So what happens is that the rocket is experiencing an upward force because of the ejection of the fuel. You also see the same sort of situation where you have an object being suspended from a string. The object has a weight and the string experiences a tension force. So you can see that Newton's third law is everywhere. For every action, there is an equal and opposite reaction. A few observations about Newton's laws in general. With inertia, you will probably come across exam questions where you have objects sliding on ice and forces being applied to them to change their velocities. With Newton's second law, you may find a projectile motion question. Usually you would be given the initial velocity and the angle, but often you might be given the mass of the object and the amount of time that a force is applied to that mass. You would have to use Newton's second law to calculate the acceleration, and the acceleration will give you the velocity. It's also worth noting that when we are calculating weight, weight is a force, we have mass, and gravity is an acceleration. So you've actually come across this second law before in your calculation of weight. Newton's third law, you might be provided with some information and have to infer the existence of other information. So you're going to have to use your understanding of Newton's third law to get more information out of the question than appears to be provided.